Welcome to this application presentation of digital image correlation, or DIC, being used for fracture, fatigue, pressure, and thermomechanic testing. Here is an overview of applications that will be presented in the fracture, fatigue, pressure, and thermomechanic testing presentation. Application 1 is a CT crack propagation test measured using the FlexDIC system. The measurement objective is to measure and plot the crack propagation, specifically the crack tip, position, crack velocity, and propagation velocity. Users can scan the QR code to watch the fracture mechanic application video. In figure 1 below, there is a schematic diagram of the fracture mechanic parameters measured, specifically the original crack width, the crack tip position, the new crack width, and the crack length and the new crack tip position. In video 1 below, the EduDIC 2D overlay visualization of the Lagrangian principal strain 1 or major strain in millistrain with one virtual line gauge element, called line 1, is plotted. It is clear to see the evolution of the major strain concentration at the crack tip during the test. Based on the DIC measurement result, the crack propagation process can be analyzed with the fracture mechanics application package. In video 1 to the left, the visualization of the major strain with analyst tools for the crack propagation contain the black frame, which is the search area, the green line, which is the crack width, the red line, the crack length, and the light blue line, which is the crack tip trace, can be seen. In video 2 to the right, users can see the fracture mechanics application module graphical user interface visualization of the major strain with analyst tools for the crack propagation. On the top right is a plot of the crack length, shown in red in millimeters, and crack width, shown in blue in millimeters over time. On the bottom right is a plot of the crack velocity in millimeters per second over time. Application 2 is a notched steel fatigue test measured using the FlexDIC system. The notched steel specimen has a circular cutout, for which along the circular cutout is a notch created on the side. The fatigue test is performed at 1 Hz. The measurement objective is to evaluate the stress concentration, specifically the strain distribution, around the local notched area with an area of interest of approximately 5 by 5 millimeters. In figure 1 shown to the left, the EduDIC 2D overlay visualization of the notched steel specimen at peak load showing the full field Lagrangian tangential strain in the x direction is shown. The x direction is defined as being perpendicular to the loading axis. In video 1 to the left, the ISTA-40 2D overlay visualization showing the full field Lagrangian tangential strain in the x direction can be seen. The change in distribution of the strain concentration around the crack tip is visible with respect to the application of the cyclic loading. DIC can provide detailed full field spatial resolution, information about the progression and mechanics of crack propagation. The total scale is 2000 microstrain and the strain increment is 100 microstrain. Figure 2 to the left shows a temporal plot of the Lagrangian tangential strain in X with respect to step acquisition. Application 3 is a CT crack propagation test measured using the FlexDIC system. A quasi-static fracture test was performed of an aluminium CT sample with length 100 mm by width of 60 mm. The measurement objective was to identify and measure the crack propagation direction and peak strain. Figure 1 shows a picture of the test setup depicting the CT sample held with CT grips and the FlexDIC system using green illumination. In Figure 2 to the left, the CT measurement test sample can be seen. In video 1 below, the ISTA-40 2D overlay visualization of the engineering principal strain, major strain in percent, can be seen. The strain concentration is visible within the area of interest. The crack propagated a length of 7 mm with a peak strain of 14%. Application 4 is a crack propagation measurement of a glued CFRP sample, measured using the FlexDIC system. Two-section glued CFRP component was tested under cyclic fatigue shear loading. The measurements were conducted according to the beat frequency principle. The measurement objective was to identify and measure the crack propagation of peak strain. In video 1 shown to the right, the ISTA-40 2D overlay visualization showing the full field engineering tangential strain in the y direction in percent is shown. The change in distribution of the strain concentration along the glue line is visible with respect to the application of cyclic loading. With every peak load, a peak strain is also detected along the glue line. This measurement is courtesy of Lima's Messtechnik and Software GmbH. Application 5 is a CT crack propagation measured using the FlexDIC system. The CT specimen was conducted according to the beat frequency principle. In video 1 to the right, the ISTA-40 2D overlay visualization can be seen showing the full field engineering tangential strain in Y. A line gauge was created perpendicular to the crack path. A temporal plot of displacement can be seen below. This CT crack propagation application was measured using the FlexDIC system. The CT specimen was measured using a quasi-static tensile test for the detection and analysis of the crack propagation. In Figure 1 to the top shows a graph of the crack tip coordinate in millimeters versus the force in kilonewton. The yellow vectors show the rapid crack growth with an associated drop in force. In video 1 to the right, the ISTA-40 2D overlay visualization of the engineering principal strain 1 or major strain with a temporal plot of the analog input load can be seen. A line gauge was created along the crack path. Application 7 is a tensile test measured using the MulticamDIC system of a wood plate with a double lapped steel joint. The measurement objective was to evaluate the stress concentration, specifically the strain distribution, around the front and side surface of the plate for a tensile test. Cameras 1 and 2 were oriented to measure the front surface, and cameras 3 and 4 oriented to measure the side surface. Figures 1 to 5 show an image of the test specimen and the individual fields of view of each camera. The MulticamDIC system can measure both the front and side surface of the sample live and simultaneously. The Tensile test was carried out until the specimen fractured. Analog input of the load signal from the test machine can be saved and synchronized with the DIC result. The test result of both specimen surfaces can be evaluated in one global coordinate system for further analysis. There is no coordinate transformation or stitching performed. Video 1 to the top shows the EduDIC 2D overlay visualization of the engineering principal strain for each camera field of view. The weaker location on the side surface can be observed through the development of the strain concentration. In Figure 1 to the right, the EduDIC 2D overlay visualization of the engineering tangential strain in the X direction can be seen at different acquisition steps. The X direction is defined in the axis of loading. A temporal plot is shown below of the analog force input in kilonewtons with respect to step acquisition. At the marker steps, the rapid propagation of the crack causes a sudden drop in load before recovery. Application 8 is a CT crack propagation measured using the EduDIC system and the DSM 5200, which is a CT demonstration sample. In Figure 1 shown to the left, there is a picture and schematic diagram of the CT demonstration sample. The crack tip opening is caused through the mechanical application of a separation load at the tip. The measurement objective is to evaluate the stress concentration around the notch of the CT demonstration sample. Video 1 shown to the right is an EduDIC 2D overlay visualization of the Lagrangian principal strain 1 with a virtual polygon gauge element. A temporal plot of the Lagrangian maximum strain across the surface of polygon 1 in millistrain was made with respect to the acquisition step, indicating a peak strain of 6.2 millistrain. Application 9 is a can pressure expansion test measured using a FlexDIC system. The soda can measurement was performed during the opening of the can itself. Pressure inside the can was quickly released through the opening, which causes an elongation of the can. In video 1 to the right, the EduDIC 2D overlay visualization of the wire displacement in microns with rigid body motion removed, together with a virtual polygon gauge element called strain gauge 1 and virtual line gauge element x in centimeter 1 can be seen. The video shows the effect that the internal pressure has on the soda can. When the can is opened, the height increases by approximately 8 micrometers and the surface strain by approximately 180 microstrain. This is measured using the FlexDIC system, which can replace other mechanical measurement techniques such as strain gauges and LVDTs. It can be used for all mechanical component and material tests and any 3D geometry and component size from 1 millimeter squared to several meters squared. Application 10 is a measurement performed using the FlexDIC system and an infrared camera of the heating of a plastic cup through the application of pouring boiling water. Measurements were required at 1 Hz for a total of 56 images. The measurement objective was to evaluate the strain and temperature of common points on the specimen surface. In Figure 1 to the top, we see a schematic diagram of the test setup with a FlexDIC system consisting of DIC camera 1 and 2 arranged on the outside of a mounting rail and an infrared camera arranged in the center. Users can also scan the QR code to watch the infrared camera application video. Figure 1 to the top shows the EduDIC 2D overlay visualization of the Lagrangian principal strain 1 in millistrain. The video shows the effect that the boiling water has on the surface of the plastic cup. As can be seen, there is a correlation between the temperature inside the cup and the surface strain. Video 2 shows the infrared visualization of the temperature from 20 degrees Celsius to 70 degrees Celsius. In Figure 2 to the right, we see the infrared visualization of the temperature from 20 degrees Celsius, which is presented in blue, and 70 degrees Celsius, which is presented in dark orange. Figure 1 to the left shows the infrared camera analysis applications package graphical user interface with the full field 2D overlay visualization of the principal strain 1 major strain on the top left and the visualization of the temperature in degrees Celsius on the top right at the same acquisition step. The DIC visualization can be shown in strain or displacement. 4-point gauge elements were created and the major strain presented in the blue line and temperature on the red line are plotted in the temporal plot shown below. Here is an overview of applications 11 and 12 performed of thermal expansion testing, measured both using the FlexDIC system. Application 11 was a thermal expansion test completed using the FlexDIC system and using green bandwidth lenses. A thermal load was applied to a sheet metal with 0.5 mm in thickness by using 2 gas burners as pictured in Figure 2. Thermocouples were used for temperature measurement and the DIC system measured the front side of the sample. The measurement objective was to measure the principal strain on the front side during application of the thermal load on the rear side of the sample. In video 1 shown to the right, we see a ISTRA 3D visualization model of the principal strain in millimeters per meter. The major strain is 15 millimeters per meter. In Figure 3 to the left, we see a graph of the temperature in degrees Celsius versus the acquisition step. The peak temperature reached is approximately 900 degrees Celsius. Application 12 is also a thermal expansion test measured using the FlexDIC system in conjunction with infrared lenses and green bandwidth lenses as well. The test object description is a steel sample of 30 by 30 centimeters in dimensions. The sample was thermally loaded up to 1300 degrees Celsius and the temperature was measured using 1 thermocouple. The measurement objective was to measure the principal strain during application of the thermal heat load. In Figure 1, we can see the DIC setup. A close-up of the front side of the measurement can be seen shown in the pink border. Figure 2, shown to the left, is a graph of the temperature in degrees Celsius versus the acquisition step. The peak temperature is 800 degrees Celsius, shown on the pink line. Figures 3 to 5 show an ISTRA 4D 2D overlay visualization of the X, Y and Z displacement respectively in millimeters at 800 degrees Celsius. Figures 6, 7 and 8 show an ISTRA 4D 2D overlay visualization of the Lagrangian tangential strain in X, Y and XY respectively. Figure 9, shown to the left, is the ISTRA 4D 3D visualization model of the grid displacement. The red grid displacement is at 800 degrees Celsius and the green is a grid displacement at room temperature. This concludes the materials testing, fracture, fatigue, pressure and thermomechanic testing application presentation. If you have any questions or comments, please contact your local Dantec Dynamics sales representative or email product.support@dantecdynamics.com.